Are you getting enough sleep? So 8 hours of sleep is the recommended amount of time teenagers should sleep. And on a typical school year, I would believe that you guys are getting way less than the recommended 8 hours of sleep per night. However, I think we're going to get some different data since we are collating this during this shelter in place order that most of you guys are probably sleeping a little more than 8 hours. But we'll see. So to test the belief that you are truly getting less than the recommended 8 hours, I took a random sample of 10 of you and recorded the number of hours of sleep each of you got. So when you guys answer that Google question, I just did the random number generator and picked 10 of your names. And you can see the raw data there. So let's run a test of significance to see, do these data provide convincing evidence that AP Stat students get less than 8 hours of sleep per night using an alpha level of 0.05. So I put the data into my calculator and I got a sample mean of 6.9 and a sample standard deviation of 1.52. I ran one variable stats on the raw data. So let's state our hypotheses. Always define your parameter of interest. So this time you'll notice a subtle shift. We went from proportion, P, to mean, mu. So the mean is going to be the true mean number of hours of sleep for AP Stats students at Corinth Holders High School. All right, so your null hypothesis. What is the recommended number of hours? 8. Your alternative? I think it's less than 8. And we're going to run a sample. Now, look, even our sample average of 6.9 thinks it's less than 8, but we'll see. What conditions must be met? Of course, random. And yes, you guys were chosen at random. Check. Independence, which that's our 10% condition. Got a little problem here. Because I picked 10 of you, is that less than or equal to 1/10 of all AP Stats students? Well, technically no, because my class has 27 students, and 10 is definitely not less than 2.7. So we do have a situation here where our independence condition has been violated. So when we finish this and we make our conclusion, I'm going to make that comment that I mentioned when we did the proportion significance test about how we're going to be cautious of these results because the independence condition was not satisfied. All right, the normal condition, when we are using means, remember we want to look at our sample size. Well, 10 is less than 30. So for your normal condition, we need to look at the graph of the data. So we've got, I'm going to come put it right up here. 5 had 1, 2 dots. 6 had 1, 2, 3. 7 had 1. 8 had 2. And 9 had 2. So I don't see any severe skewness, no outliers. So since the graph of the data did not have any skewness or any outliers, we can say the normal condition is met. So no skewness or outliers. Oops. All right, so the formula for the mean and the standard deviation of the sampling distribution of X bar from chapter 6, the mean of the sampling distribution is equal to mu, and the standard deviation of the sampling distribution is the sample standard deviation divided by the square root of n. So the mean of our sampling distribution is 8. And the standard deviation of our sampling distribution was 1.52 divided by the square root of n. So 1.52 divided by the square root of 10 is 0.48. So this n was 10. Draw a picture and calculate the test statistic. All right, so we said it was going to follow, the sampling distribution follows the normal curve. So our test statistic is going to be remember how it's your statistic? So x bar minus the parameter, standard mu, divided by the standard deviation of the sampling distribution. Well, just like when we did confidence intervals for means, our test statistic here is going to be t. T is going to equal the test statistic that we will be using when calculating the p-value. All right, so t is equal to x bar, which was 6.9, minus 8 divided by 0.48. So 6.9 minus 8 divided by 0.48 is negative 2.29. That probably should be a little further down. So remember, this is our p-value. We said less than, so that's why we shaded to the left. All right, so our degrees of freedom are going to be our sample size minus 1. So our degrees of freedom are 9. So let's find our p-value. Now, you're welcome to use table B, but most of you are going to do inverse t, lower, upper, degrees of freedom. So inverse t, lower was negative infinity, upper was negative 2.29, degrees of freedom are 9. So remember, our test statistic is right here, negative 2.29. All right, so second bars, inverse t, why am I doing inverse t? Nope, I should be doing inverse, no, I should be doing TCDF. It's I. Okay, so let me erase this. So you guys, I had the right parentheses, but it's not inverse t. You use inverse t when you're finding t star, but we're not finding t star. So we're doing TCDF. So our lower is negative infinity, our upper is negative 2.29, our degrees of freedom are 9, and we get a p-value of 0.024. So what conclusion can we make? Since our p-value of 0.024 is less than alpha, we will reject our null hypothesis. We have convincing evidence that the true mean hours of sleep for AP Statistics students at Corinth Holders High School is less than 8 hours. All right, so your significance test for mu. Oh, I forgot something. But we're going to put a little star here. Since the 10% condition was violated, be cautious using this result. Same exact conditions that we checked in Chapter 8 with confidence intervals. Just remember that if a condition is not met, proceed anyway. Include, we must be cautious of our results as the blah, blah, blah condition was not satisfied. So remember to check your normal condition. There are 3 things you could check. If you are told your population is normal, it doesn't matter what size your sample is. Your sampling distribution will be normal. If your sample size is less than 30, you must graph your data, look for outliers or strong skewness, as we did in this example. If n is greater than or equal to 30, the central limit theorem applies. So your test statistic is going to be x bar minus mu divided by that standard error, so the standard deviation divided by the square root of n. Degrees of freedom is n minus 1. Use table B with degrees of freedom and the tail probability, or your calculator at TCDF. The calculator will be more accurate than the table because your table doesn't give you every single possible degrees of freedom. So let's do an example, but we'll follow the 4-step process this time, and you can see a significance test for means in action. The level of dissolved oxygen in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the DO level at 30 randomly chosen locations along a stream. Here are the results in milligrams per liter. X bar is equal to 4.77, and the standard deviation of your sample is 0.939. An average dissolved oxygen level below 5 milligrams per liter puts aquatic life at risk. Do the data provide convincing evidence at the alpha equals 0.05 significance level that aquatic life in this stream is at risk? So your parameter, mu, is the true mean DO level. Your statistic, X bar, is 4.77. Your hypothesis, your null, is that the mean is equal to 5. But we suspect, or we want to see, do we have less than 5? Because less than 5 means that the aquatic life is at risk. So our alternative is going to be mu is less than 5. Our alpha level is 0.05. And you probably have suspected that the name of the procedure is a one-sample t-test for means. So it's a one-sample z-test for proportions and a one-sample t-test for means. All right, so the conditions, random. Check, it was stated in the problem. Independence. Our sample size was 30. So we did a sample size of 30 randomly chosen locations along the stream. So is 30 less than or equal to 1/10 of all the locations down the stream? I think it's safe to assume. And then normal, since 30 is greater than or equal to 30, the central limit theorem applies. So we are able to say the sampling distribution is normal. All right, your general test statistic is in your formula sheet. That's the one where you're going to use words. So your test statistic is equal to your statistic minus your null divided by the standard deviation of your sample. So more specifically, that's going to look like T, remember means is T, X bar minus mu divided by the standard deviation of your sample divided by the square root of n. So T is equal to 4.77 minus 5. Remember that comes from your null hypothesis. And then your standard deviation was 0.939 divided by the square root of your sample size, which is 30. So your test statistic is negative 1.33. So t equals negative 1.33. Draw our picture. We said less than, so we're shading this side, and that's going to give us our p-value. So t CDF, negative infinity to negative 1.33. Degrees of freedom. So it's going to be 29 degrees of freedom because it's your sample size minus 1. So your p-value is going to be 0.097. So in conclusion, compare this to our alpha level. Since our p-value of 0.097 is less than alpha. Oh, wait, it's not less than, it's greater than alpha. What am I doing? I forgot our alpha level for a second. Greater than alpha, we will fail to reject our null hypothesis. We do not have convincing evidence Now remember, if you get stuck, look at what you're trying to find, and they're lovely. They write it so much better. Do data provide convincing evidence at the alpha equals 0.05 significance level that the aquatic life in the stream is at risk? We do not have convincing evidence the aquatic life is at risk.